Today, I'm going to show you how to create a GraphQL server with GQLGen. This bad boy is production ready and lots of people are using it. A very active project. So let's get started. First, let's go ahead and follow the instructions here. Go to projects. I'll just make GQLGen tutorial. And if I go inside to GQLGen tutorial, I'm going to follow these instructions. First, go mod init. So first you need Go installed on your computer, and if you don't know how to do that, just go to Google, type install Go, and you have different options for installing Go here for different systems. I'm on Mac. I actually I suggest using Brew if you're on Mac, Homebrew. So Brew install Go or something like that. Right. It's just easier to manage with this if you're on Mac. If not, you can just follow these. Windows, you have an MSI installer thing that you can use, or whatever. So let's get back to the program. I have Go installed, as you can see. If I type Go V, it shows version or something. It shows 1.17. So go mod init GQLGen tutorial. Created a new go.mod file. I'm going to copy this command. This is actually new, I believe, recently added. I'm just going to run that. And this is the most important part, I believe, because we initialize the GQLGen and all of its config files. And we're going to try to run the server, see what happens. It's on localhost 8080. So we have a server here. Let's see what the schema looks like. Okay, the schema looks like this. To do, user, so what is a schema, first of all? Well, a schema is kind of like a DB. Each of these types is kind of like a table, with the exception of query type and mutation type. Query type tells you what you can query. Mutation type tells you what you can change. In this case, to do is probably like a sort of table, and with these kind of columns, ID, text, done, which is a boolean, true or false, and user. User is another type of table with ID and string. And in here, mutation tells me what I can do. What I can do, I can create a to-do, which is one of these, with an input of new to-do defined here, new to-do. And all I have to provide is the text and the user ID. And it will return to me a new to-do. So this defines kind of what I can do. And the last one is query. If I query to-dos, I should get a list of to-do objects. And you might be thinking, what does the exclamation point mean, and why do some things have exclamation points, some things don't? Exclamation point just means that it's mandatory, that it's required. So this input cannot be empty. It must contain a new to-do input with text which must contain text and a user ID, and it must return a to-do. Otherwise you're screwing up, my man. You're screwing up. So if I follow these instructions and I just go query to-dos. Okay, I need the subfields. Within to-do, I want to get the ID, the text, done, and user. I think in user I need to get the ID and the name as well. If I do that, it shows me internal system error. And that's because we haven't implemented anything. We haven't coded anything. So let's start with that. So this is just an example schema. Obviously you can have your own custom schema depending on what you want to do. But if you notice, the schemas are actually right here. You can define this however you like. This one's just the one, the demo that we're doing here. So you, like as I said earlier, we have a to-do. Wait, let me make the font bigger. Maybe 18. Yeah. So we have to-do, which is kind of like a table in a database, right? We have user, which is also kind of like a table in a database. The only two that are not are these. So input just defines what I'm able to input. If I do a mutation here, I don't think the server is running anymore, but it's cached, I guess. But if I do a mutation here, I can do create to do with the input of create to do with the input of new to do, which has text and user ID. And this should return to me a to do back, which has ID, text, etc. So to ID, text, done, user ID, name. Basically the same as this, right? Except it's here. So this is kind of the way to write GQL queries or GraphQL queries, and it's well documented on the GraphQL website itself. So if you ever have problems, you can start looking at this, and it kind of teaches you how to do the queries, how to do the mutations, etc. But these are kind of the basic ideas. If we want to implement GQLGen or GraphQL server in Go, we start with this, and we're going to stick with this because this is simple to follow, right? Obviously, when you're building your own application, you're going to have different things here, but we're going to stick with this because it's simple. Now, if we look at the code, this is actually what's the main function is running. And if you're not familiar with Go, it's okay. Whatever's in the main function is the one that gets run. So you can see that you don't really have to worry about the details, but all you have to know is that the slash endpoint, which means no endpoint, as you can see there's nothing behind the slash, is hosting the GraphQL playground. And you can see that GraphQL playground is here, right? Oh, no. Okay, so the slash is hosting the GraphQL playground, and the slash query is hosting a server, the GraphQL server. So this is where GraphQL queries. When I press play, we're actually making this request to the slash query endpoint. What do I mean by that? Well, if I run this, wait. If I run this and I go to slash query, you see that there's nothing here. Because I'm here when I'm doing it through the browser, I'm actually making a GET request. Whereas in GraphQL, what you need to do is you need to make a POST request. So if I go to postman here, and let's see, let me make a new request, and I make a post, or actually there's a GraphQL option, I believe. I make a post request to localhost 8080 slash query, and I copy this I get the exact same response as I would if I played it here. See? Exact same. So the GraphQL playground itself is hosting the UI, whereas the slash query endpoint is hosting the actual GraphQL server itself. So this is kind of a UI front end to actually access this. In order to access this, you need to make a post request. So hopefully that makes sense so far. And if it doesn't, that's okay. So we are just serving both of these on localhost 8080. And the default port here, you can always change that if you need to. Okay, so that's the main function. Let's get to the resolvers. Now, what are resolvers? Resolvers are basically, if you see here, I have an internal system error. Why is that when I query to-dos? Well, if we look at the generated files and we go to schema.resolvers.go, you can see it's actually all here, the code that runs when I make this query. You notice that it's error because nothing here has ever been implemented. So here we need to actually define ourselves what we want the program to do, or we want the GraphQL server to do when someone gives us this query. So if I query all to-dos, I want a list of to-dos back. Okay. So for example, in my model.todo, it's auto-generated to have all this stuff. What do I mean by that? If I go here and type return model, let's see, a list of models dot to do pointer, by the way, this is a pointer. You don't have to worry too much about this quite yet if you're not familiar with pointers, but in this case it also just means it's nullable. If you don't put this, you can't null this value, which what I mean by that is that a pointer is actually the address, the memory address of this this variable. So it's not the value, it's the address. So what I mean is, let's see, if I go to like a Go playground. So if I run this, hello world, this will type hello world. But then, so if I have a string called example equals colon equals is the assignment operator in Go, hello world, and I print the address of the example and example. So there's star and star is a type of address, but then to get the actual address itself you need to use and. I'll show you what that means, but if I print and example, it'll give me some weird code, right? This is the address of where hello world is being stored to the program. If I run this again, it should give me a different one. Yeah. So every time it's saving to a random memory address that's free, basically. And when I say that I want a pointer type of reference to example, equals to, or sorry, is a pointer of a string, and I go reference to example equals to example, and I print reference to example, notice that and example fulfills the requirements of star string, because you're taking the address of the string itself, which is this. And the reason that Go does this is because sometimes you want to pass by reference instead of passing by value, meaning you save memory by giving the exact memory address and modifying the value for that particular address. That makes sense. It doesn't have to, but the other side effect of this is that this could also be null. So if I, or nil. So if I, let's see, example declare not use. Oh yeah, so there's no unusable examples here, so. Right, so in this case, reference can be nil, but if it's a normal string, the Go won't let me use nil. So that's one side effect of using a pointer. Right, so if I want to print the text itself, so let's say this is an example, and here I just always print the address, but if I want to print this string itself, I do something called dereferencing, which means I add another star here. If I add another star here, actually dereferences this address back into the value. So the other like benefit of using pointers is that not only can I get the memory address, I can also get the value that's stored in that memory address by just using star. So it's like quite useful. So that's the meaning of the star here. And I went in a lot of detail about that, but I think it might help someone who doesn't understand what pointers are, and hopefully that made sense. So I have a list of pointers to to-dos, and you see in to-do there's 4 fields or columns. If I go so in this list of to-dos of models, I have to have the memory address of one of the models.to-dos, and in VS Code I actually have this fill model.to-do. It'll give me all the stuff, so I can fill this in. 1 2 3 testing. User is also a pointer to a model.user, and here I can also fill that in. User ID user 1. Name is Elmo. Okay, so if I look at this, okay, so I can return this list of models, and this error here, I also have to return an error. So I have to return a model.to-do, and also have to return nil as the error. Error type can be nil. Redundant. Oh, okay. I guess, I don't know, it's redundant. I don't know, this seems more clear to me if I do that. Now if I run this server, go run server.go now, what do you think is going to happen when I query this? I get the exact object that I return. So what we have done simply is, I want to explain to you that the query, you can write any amount of logic for your program. At the end of the day, all you need to do, the requirement to fulfill this function is you need to return a list of to-dos, right? So list of to-dos, which I kind of create an example of. Now if you want to go further, we want to make this a real thing, right? So let's say I want to actually implement the mutation as well, where I need to create a to-do and add it to a list. Well, first we need to store this list somewhere. We can't just return this. We need to return it from somewhere, which we can modify. So let's do that. Let's go to resolver.go. Here you see the best practice here is usually to store the state in this file. So here I would have a, let's see. Here I would have a to-dos, which is a type of model, which is a list of pointers to model.to-do, to-dos, resolver.to-dos, right? And here, if you notice this R, so in Go, this means that this create to do is actually a function of this object. So this is R dot create to do, R dot whatever. So if I go here, it's actually R dot to do's. I can access this entire list anywhere in here. Anywhere where there's an R, I can access it. R dot to do's. So instead of returning this fake model we created, let's just comment this out just in case we need it. I can return R dot to do's and no. And it's giving me an error because model.to-do, model.to-do, to-do. can't we use it? Oh, I see. Because this is also called to-dos, I can't have the same name. To-dos list. To-dos list. Okay, so here I just return r.to-dos list. I had a name clash there because this to-dos is also the name of this, so I gotta name this differently. Okay, so r.to-dos list, and it's empty right now. So in our mutation, which is here, by the way, create to do, it also has an input of which we put input text and user ID. So all we have to do on the mutation is add to the list of to-dos. So first we have a to-do object. Remember, colon equals is the easiest assignment operator. Is equal to a new model.todo. And in VS Code, if you have all the Go like helper tools, you can just press fill in and it'll help you fill in the model.todo. And here I'll just follow this 1 2 3 testing false dot user. I should also have a fill in here. Fill model.user user1 Elmo. Okay, let's see what's wrong. Yeah, I think this is and model.todo, right? Yeah, so it's really confusing, but and model.todo gives you the actual address. Star means that it's a type of address. It's like really confusing, but yeah. So now all we have to do is, instead of actually implementing this, oh my bad. So we have the input of the model, right? So what we actually want to do is, instead of this text, we actually want to take the input.text. And in the user, wait, what else is required? User ID. So user ID is here. So we also want to put input.user ID here. Now for the ID, we don't want it to be the same. So we'll do a length of to-do. Length of r.to-dos list plus 1. And make that whole thing into a string. So we're just taking the current list. So right now it's 0. So the ID would be 1. And then if it's 1, the ID would be 2, etc. So, and then name, we'll simply do a sprintf. This is a formatting thing, so what I can do basically is, right, we need to import fmt obviously. And we're gonna have a string of length to-dos list plus 1. So we're going to have Elmo 1, 2, 3, 4, and ID 1, 2, 3, 4. Depending, and then the user ID and the text is up to the input. And we're just going to append this to r.todos list. And all we have to do here is return to do and nil for the error. fmt.sprint. String of 1 rune. I don't know what that means. I don't know what this means. But this should suffice. So let's run it. Now if I query this, I have an empty list obviously. But if I do a mutation now, and I go create to do, requires an input of text and user ID. Text, wash the dishes. Wash the dishes. User ID 10456. It's going to return to me in ID text done. So if I run that, let's see. Oh, right. So I have to get rid of this. If I run that again, internal system. What's the problem here? Invalid character. I think that this does not work. So I'm just going to do sprint. And I believe this properly converts it to string. So according to the hint at least. I just follow the hints. There you go. Created a to-do. And if I query all the to-dos now. Let me just create here. To-dos. ID, user, name. Done. What else was there? Text. I get 1 task. Now let's create another task. Clean the toilet. Also assigned to 456. And I query all the to-dos now. Now I have 2 tasks. From Elmo 1 to Elmo 2. And the way we define is just the length of the to-dos plus 1 over here. So that's how you do queries and mutations. That's it. At the end of the day, you're the one implementing the logic. So you could connect this to a database, do whatever you want. At the end, all you have to do is just make sure that here, when you resolve the queries, you make sure that you return the correct values. And that's all I have for you guys. I hope that you learned something, guys and gals. I hope that you learned something. Stay safe and go on hacking. Thank you.